Hello and welcome to m252 Calculus 2 here at Cañada College. My name is Lapuz. In this video we're going to do checkpoint 5.6. This is coming from section 5.1. It says to consider the sequence a sub n defined recursively such that a sub 1 is equal to 1, a sub 2 or a sub n is equal to a sub n minus 1 over 2, and then use the limit monotone theorem, convergence theorem, to show that the sequence converges and find its limit. Here is the theorem that says that if a sub n is bounded, a sequence, and there exists a positive integer n sub 0 such that a sub n is going to be monotone for all other sequence members that are bigger than n sub 0, then a sub n converges. All right, it might be good to kind of gather some information first and try to figure out what this particular sequence looks like. We have 1. A sub 1 is equal to 1, so we start off with 1, and then a sub 2 is going to be a sub n minus 1, so that previous number divided by 2, so this is going to be 1/2. A sub 3 is going to be that previous number, that's 1/2 divided by 2, so that's going to give you 1/4. So that's our next number, 1/4. A sub 4 is equal to the previous number, which is 1/4, and then we're going to divide that by 2, so that gives us 1/8. So this is going to be 1/8. So I think you can kind of see the pattern here. We can actually write an explicit expression for this if we wanted to. And I think the explicit expression is going to be 1 over this number 2 squared, 2 to the third, 2 to the nth power. Okay, and then we'll put ... to say this is going to be an infinite sequence. So now, what do we need to check? We need to check a couple of things for us to be able to use the monotone convergence theorem. We have to check that A is a bounded sequence. So A is bounded. Let's check if a sub n is bounded. So it starts off with 1. Let's take a look at this from a graphical point of view. It starts off with 1, and say that's 1, and then it goes to 1/2, and then it goes to 1/4, it goes to 1/8, etc. So now the question is that it looks like it's bounded on top by 1. So a sub n is always going to be less than or equal to 1. Now the question is this going to go down, ever going to go down below 0? And it looks like 1 over 2n is always going to be bigger than 0. In fact, I don't think it'll be ever equal to 0, so we can say that this is actually bigger than 0, or you can say that 0 or a sub n is bigger than 0, or you can say a sub n is, or 0 is less than a sub n, which is less than 1. So this certainly proves that it's bounded. So we can check that off. And then now it says there exists an integer such that a sub n is monotone. So monotone means it's always going to be increasing or always going to be decreasing. So you can see that it looks like it's always going to be going down. In fact, what we can say is that a sub n is always going to be bigger, or the next one is going to be always less than the previous one, a sub n minus 1. And that shows that it's monotone. So we can take a look at 1, or a sub n, like the 1/2 term is going to be less than the previous term, and then 1/4 is going to be less than the previous term, etc. So we can say yes, it's monotone. That checks out. And once we show that, well, we show that it's bounded and monotone, then therefore the sequence converges. Now the next question is that where does it converge to? It says if it converges, find its limit. And we can kind of see from the graph that it's going to keep going down, and it has a boundary of 0, so it looks like it'll approach 0. What we'd like to do is take our explicit term and find the limit as n goes off to infinity of 1 over 2 to the nth power. And we'll see that this whole denominator just goes to infinity, and this is going to go to 0. So that's we came up with our conclusion, and then we found the limit, which is going to be where it converges to. Okay. All right. I hope that helps. Good luck.